Hi, this is Mrs. Sherry, and welcome to Virtual Learning. The first topic we will discuss will be divisibility rules. So for divisibility rules, you need to get some things ready. So you'll need to have your interactive notebook. So that should be set up for those of you that I've seen in person already, that you've got your dedicated notebook that you're not tearing pages out of because we're going to use the whole thing, creating our own reference. And the table of contents page will be in the front, and you've got an envelope and a Plickers code in the far back. You'll need a pencil to take notes, and of course, you'll need to be paying attention. So if your interactive notebook isn't set up yet, you can watch for a short time more, but then you should really set that up before you finish this portion. So here's my trusty interactive notebook, and mine is plastic, so I just wrote on a Post-it note and taped it on here. I used my label maker to put my name on there because it's not cardboard-ish. So this is mine, and I recommend the composition kind of book just because then if you look over at the binding, the pages aren't perforated, but that's not mandatory. I just recommend that. Sometimes the downside is that the pages ended up being a little bit smaller. But you'll need to set up your page for your notes. So divisibility rules, that's the topic, so you can put that at the top. Then you can see right along here, I folded my sheet of paper in half so I could see where the center was. And then I numbered from 1 to 12, but look what I forgot, 0. So you could add in 0 however you want to. Start with 0, or if you want to center 0 here and then do 1 through 6, 7 through 12. Rule number 7 takes up a little bit of extra room, so give yourself some extra room there. But like 1, 2, 3, those are shorter ones, 10. But you're going to want to go from 0 to 12. So you can put them on your paper however it works best for you. So if you need to still set that up, please pause, and then you can start up again once you've got your note-taking page set up. Okay, so since you're watching, I'm assuming that you've got your numbers from 0 to 12 with your label across the top. Then remember, every time we make an entry in our interactive notebook, that, remember, gets to be used on all of your tests and quizzes. So the more diligent you are about taking detailed notes and writing down examples and vocabulary, the more you're going to be helping yourself in the future. So please go to the front, and whatever pages you used, I'm assuming you probably used like pages 1, maybe page 1 and 2. It's okay to take pages 1 and 2 because we're going to be taking some more notes and doing some more examples. But whatever page you used, and I'm assuming 1 because it's our very first entry, and then right here you're going to write divisibility rules right here in the topic area. So please get that done before you go any further. So pause the video if you need to do that. And next, I'm going to have you leave this screencast and go to a different one first, because this one will give you practice after you've learned the rules. So pause this screencast and you can see at what point you're at, so you can just scroll ahead. You don't need to watch the beginning part again. And you're going to go use the Show Me link. And I included that in the Google Classroom post. So check out Mrs. Sherry's Show Me. That has to do with divisibility rules. And you will notice that not every single number from 0 to 12 is addressed in that screencast. But by the time you come back to this one and finish and with your practice, then all of the numbers from 0 to 12 will be covered. So don't get nervous if you, by chance, think that you missed one. You didn't. And with any screencast, remember you can always pause, rewind, or re-watch the whole entire thing. That's the benefit of having a link like that. So again, here's where you're going to stop. Go back to your Google Classroom and click on the link for the Show Me, and that's what you'll start with taking notes. Okay, so one last reminder, please make sure that you finished your notes on that Show Me, and now you've scrolled back ahead to finish this screencast where you can go fill in some notes and also get some practice with using divisibility rules. And this is something that I will test your knowledge on after by having some assignments, quizzes, and also playing our Plickers game. So as our second review here, we talked about divisibility rules for numbers from 0 to 12, but this is the first time that you're getting notes on 0. So here's where you're going to want to have a spot for that. So 0, a number divided by 0, you can see that says no. So instead of using our typical line with 2 balls for division, in 7th grade, we use the fraction bar. And just like we stop using the X for multiplication and we instead use a dot. So a number divided by 0, no. So you could add this graphic to the part with the 0. So don't do it. Divided by 0 is undefined. You cannot break something into no groups. So this graphic shows you that. And this is not the same as dividing 0 by a number. If you divide 0 by 5, that one is okay. But the opposite, a number on top divided by 0 on the bottom, can't do that. Next, so 1, this is probably the easiest. There is no rule needed. All integers are divisible by 1. 1 is a factor of all real numbers. So what's divisible by 1? All integers are. So there's not really a rule, but you can put this down. All integers are divisible by 1, and 1 is a factor of all real numbers. So include this part on your notes page. Also remember, if you think I'm going too quickly, you can always pause so you have more time to write, or you can always rewind or rewatch. So if you think I'm going too quickly, you have that choice if you wish. Next, divisibility by 2. Is it even? All even integers are divisible by 2. And the way you know if a number is even numbers, that means that it ends in 0, 2, 4, 6, or 8. So if it ends in 0, 2, 4, 6, or 8, then that means that it's even. And if it's even, that means that it's divisible by 2. So you're going to simply look at the number in the ones place. So are any of these numbers divisible by 2? Well, check and see. Do any of them end in 0, 2, 4, 6, or 8? Are any of them even? So take a moment, you can pause, see which ones you think would fit that. And here we go. The bottom 3 are. Numbers ending in 3 or 1 would not be, but ending in 4, ending in 0, those definitely are. Divisibility by 3 is the sum of the digits, or that's the digital sum, divisible by 3. So the sum of the digits, you should know that sum means that you're adding, and the digits, that's just the individual numbers that make up the whole number. So you're going to add the numbers together. So 12, the digital sum would be 1 plus 2. and that equals 3. Is 3 divisible by 3? Yes. So that means that 12 is divisible by 3. So sum means adding. The digits, that just means the individual numbers. So if the digital sum is divisible by 3, then the whole integer is. So, are any of these integers divisible by 3? So go ahead and add up those digits and see what you get for a total. And is the total divisible by 3? If so, the whole integer is divisible by 3. So pause a moment and see what you think. Okay, now that you've had time to pause and practice, here 1 plus 6 is 7, so that doesn't work. 7 is not divisible by 3. 1 plus 2 plus 3, that works because that digital sum would be 6, and 6 is divisible by 3. The third one down, 2, 4, 6, excuse me, 2, 4, 6 plus 12 more, that's 18, and 18 is divisible by 3. Is 0 divisible by 3? 0 divisible by 3, so it's not a number divisible by 0, so then yes, that works too. And then 81 million, 8 plus 1 is 9, plus all those zeros, just use it at 9, so that works as well. Divisibility by 4, are the last 2 digits divisible by 4? So no matter how big the number is, so I could write numbers all day long, and then I'm going to just look at the last 2 digits. So 44, is 44 divisible by 4? Yep, so this whole number is. You only need to look at the ones place and the tens place. If the last 2 digits are divisible by 4, then the integer is divisible by 4. You should notice I keep saying integers because we're not talking about rational numbers, which would be decimals or fractions. So integers. So are any of these divisible by 4? So let's look at the last 2 digits. This one only has 1 digit. The last 2 digits, and are they? So pause, take a moment and see what you think. 16 is divisible by 4, 44 is, 0 is, 0 is. So those are the 4 that work for that case. 5, this one's one of the easier ones that I bet when you guys were younger and you learned how to count by 5s. Is the last digit 5 or 0? So again, you're just going to look at the last digit. If the last digit is 5 or 0, then the integer is divisible by 5. So do any of these follow the rule for being divisible by 5? So see which ones you agree with. Okay, hopefully you've had a chance to see, and ending in 5 or ending in 0, that makes those work out. For 6, this one, you simply, there's no rule of its own. Is the integer divisible by both 2 and 3? So you look at your rules for 2 and for 3, and it just has to follow or has to like pass the test for being divisible by both 2 and 3. So if it fits both of those, then it's divisible by 6. So 6 doesn't get its own rule. Let's see what our choices are. So let's check out these numbers. Are any of these divisible by 2? If not, you can cross them off right away. Are they divisible by 3? If not, you can cross them off right away, but if they pass one test, then you can try the other test. So pause and see which ones you can figure. Okay, and these last 3. These 3 are all even. They end in 4 and 0 in this case here, and they also have a digital sum that's divisible by 3. The rule for 7. Now this one is a little bit of a trick, and we'll practice it, and I think you'll be really proud of yourself. It seems like it's super confusing, but we'll practice to see whether numbers are divisible by 0, and I think that you'll have a good time. So the algorithm just means the process or formula to follow of whether an integer is divisible by 7. So here's how this works. If you double the last digit, double means times 2, subtract it from the rest of the number, and if the answer is 0 or divisible by 7, then the entire integer is divisible by 7. However, if you are in a time crunch and you need to, just divide by 7. That's fine. But if you want to try the algorithm, sometimes that is kind of fun, and I'll show you how that works. So let's try it with 40,824. So the rule says that you take the last digit, so we're going to take this digit off of here, and we're going to double it. So 4 times 2, and that equals 8. And now we're going to bring this back here and subtract 8 from the remaining parts of the number. So that number you take off to double, it doesn't come back there. Then we subtract 4,082 minus 8. That's going to give us 4,074. Now we'll repeat that process. So it ends in a 4. We're taking that number away. 4 times 2, and that gives us 8. So we're going to bring the 8 back over here and subtract it from the part that's remaining. So we are going to have to borrow here. So we get 399, and last digit, we're going to take that away. That's 9 times 2 is 18. So the 18 will come back over here. 39 minus 18 is 21. Now we'll take that last digit away, 1. Take it times 2. 1 times 2 is 2. We'll bring that back over here, and we get 2. And 2 minus 2 is 0. So then, yes, it works. We could have stopped right here even, because the rule says if your result is divisible by 7 or is 0. So 21 is divisible by 7, but down here we got 0. So that's just one example. Please do not feel like you have to have this task mastered at this point. We will do many more in class. So 35,616, you go ahead, try that one. So you're going to remove off the 6, double it, get 12. You're going to bring 12 back here and subtract it off. And when you subtract that, go ahead and figure that out. So you're going to have to borrow. So we're going to get 3,549. Take off that 9, double it, and we get 18. So 354 minus 18, you're going to have to borrow again. And I'm going to have to go up to the top here. So you're going to get 336. Take off your last number, which is 6, and double it, which gives you 12. Bring 12 back here. And we get 21. And 21 is divisible by 7, or we take off that 1, double it and get 2, subtract 2 and we get 0. So that number works as well. So here's just an example that you can write that out in your notes. So you've got a few step-by-step examples. I'll let you try this one and you can see whether that one works or not. 26,136. Are any of these integers divisible by 7? So again, you could try the algorithm or you can just divide them by 7. So pause and give that a little chance. Okay, after pausing, hopefully this is what you came up with. It's 693 and 0 both work. For 8, a number is divisible by 8 if the last 3 digits are divisible by 8. So if the last 3 digits are divisible by 8, then the whole integer is. So are these divisible by 8? Well, 34, it doesn't have 3 digits to end, but you should know, is 34 divisible by 8? No, because 8 times 4 is 32, so that's not going to work. 121, is that number divisible by 8? Well, 121 is odd, so that could come into play there. This number, so 444, is that number divisible by 8? Is 0 divisible by 8? 0, 0, 0, is that divisible by 8? So if you don't have 3 digits, you just go with whatever you've got there. And here are the ones that work for 8. For 9, this one is very similar to rule 3. Digital sum, so the sum of the digits, if that is divisible by 9, so you add the numbers that are in that number. And is it divisible by 9? So this is similar to the rule for 3. There was, for 3, is the digital sum divisible by 3? So try these out. If you get the digital sum for these numbers, and is that sum divisible by 9? So 1 plus 9 is 10. Is 10 divisible by 9? No. 1 plus 2 plus 1 is 4. Is 4 divisible by 9? And etc. So keep getting your digital sum. Pause and you try, see what you get, and then you can compare on the next page. Okay, so just these work. This digital sum is 18, and 18 indeed is divisible by 9, and 0 is divisible by 9. 10, does the integer end in 0? So this one is really easy. You can just look at it. Does it end in 0? So are any of these divisible by 0, or by 10, excuse me? Do they end in 0? Those are pretty fast to determine whether or not they're divisible by 10. And you can see the bottom two there worked out. So you should already have rules for 11 and 12 from the previous screencast, but we will use divisibility rules all the time, all year long. So the big concept, big idea is having this in your knowledge base will make your math life so much easier. So if you need to go back, pause, rewind, if you want to do a few more examples on your own, any extra initiative you take, you can beef up your notes as much as you want to. Remember, as long as it's your handwriting that you put things into your interactive notebook, then it's yours to keep. We have the table of contents because everybody's pages will be a little bit different. So if your divisibility rules takes up 4 pages, then that's fine. Just indicate so in your table of contents. So math rocks and so do you, and we'll see you next time.